Hello, my name is Nikola Georgiev, and I absolutely love math. However, I feel that learning math without relating to the real-world applications behind it can really cause one to wonder, why am I learning all of these formulas and concepts? Knowing the applications behind the math you're learning can really cause it to be a lot more engaging. One area of math that actually requires application to be understood is game theory.
Game theory is the study of decision-making during conflict and competition, and it isn't limited to traditionally known games. Rather, it can be used to find solutions to real-world problems by treating them as a competitive game. Game theory assumes that the theory of rational choice holds true, which means that the players will take the most rational decision every time, or the strategy that results in the greatest benefit for the least risk. Game theory has applications in many areas of science, economics, and psychology because of this assumed rationality. Games can be analyzed differently depending on several characteristics. In cooperative games, players communicate and decide on a strategy that has the best outcome for all of them. Non-cooperative games are more interesting to analyze though because every player is trying to decide on the strategy that would benefit only themselves the most. Normal form games would use matrices to portray the possible strategies each player can choose, but rely on the fact that both players pick simultaneously. Meanwhile, extensive games are in the form of a game tree and show the sequence in which the players choose their strategies consecutively. Zero-sum games occur when the sum of all the possible outcomes for both players equals 0, meaning that, for example, in a two-player game, one player's loss will always be the other player's gain. Non-zero would then mean that the total sum of the outcomes can be positive or negative. Now that we have a basic understanding of game theory, let's make it more interesting and take a look into how it can be applied in the real world using the famous prisoner's dilemma. In this game, two men are being interrogated after committing the same crime, so both are given 2 years in jail. However, the police get suspicious that they might have been involved in a much greater crime, and the prisoners are separated and given 3 options. If one of them confesses about the greater crime, but the other does not, the confessor will get a sentence 1 year shorter, while the other will get a sentence 10 years heavier. If both of them confess, they will both get a sentence 2 years longer. However, if both keep their mouths shut, then they will only be given sentences for the original crime. This problem can be represented by a normal form, non-cooperative game, showing the payoffs of each strategy. We get a negative sum game because the sum of all of the payoffs is negative. This makes sense, since spending time in jail is definitely a negative experience. The solution of this game would be for both prisoners to keep quiet, since that has the overall least negative payoff. However, say that the men are suspicious of each other. Then they would be best off confessing, because confession has lower jail times no matter what the other man does. Even if the best outcome is obviously when the two men keep quiet, confession is almost always picked due to the lack of cooperation as well as pure self-interest. It turns out that this game can be used as a model in many real-life situations. Let's look at a specific example to display the usefulness of understanding game theory and prominent games like the prisoner's dilemma. Consider the rivalry between two leaders of the smartphone industry, Apple versus Samsung. Suddenly, Apple decides to decrease the price of its newest flagship phone as a competitive move. Using the prisoner's dilemma, we can display different options and potential outcomes for Samsung now that Apple have lowered their prices. We could set up the prisoner's dilemma to look like this, by taking the values from the original and increasing each by 2 to make the values more intuitive and appropriate for our problem. Cooperation between Samsung and Apple now becomes 0, 0. Of course, the values in the table are only substituting much larger figures, in this case most likely in the billions of dollars. We can clearly see that if Apple decreases the prices, Samsung will be forced to do the same in order to retain market share. But then, both companies would suffer from lower profits due to less money made per phone. Hence, the scenario where Apple sticks to the implicit agreement to keep prices high and doesn't cut the prices is definitely the best way to go.
There you have it. Using tables and game trees to solve real-world problems. Game theory is truly a fascinating area of math that I feel isn't talked about often enough at school or at math competitions. Yet, now that I've introduced you to it, I hope you have the urge to learn more about game theory. Thanks for watching.